Hey, welcome back to AP Computer Science, and we're going to continue talking about polymorphism. And I want to go back to something that we did last year with this little bouncer. And this is a good example of why polymorphism is useful. So if you remember, this bouncer has all these different types of objects in it. We have circles, wheels. Actually, I haven't created any wheels, so let's create a wheel here. And rectangles and beach balls. So there goes the wheel. I'll create a couple of those. And the beauty of it is this bouncing panel on the left side here doesn't really even think about what type of sprite it's bouncing around. It just knows how to bounce sprites. And then the sprites themselves know how to draw themselves and so forth. So we're going to look through the code just to recall how this works, but this is a good example of why polymorphism, what we're learning right now, is very important. And all this code is in Code from Class from Unit 8, so I encourage you to go look at it, play with it, extend it, and all that. So just kind of dig in and make sure you understand what's going on. So let's look at bouncing panel first. So bouncing panel is that left panel, and it's responsible for holding the sprites and working with them. And so the first method to think about is it has an add method. And so whenever the user wants to create a new sprite, this is the method they'll be called to add the sprite to the panel. And it just adds it to an array list. And then we're using swing for this. So this is the older form of graphics for Java. I haven't updated it to Java FX, but it's using a timer object. So every 30 milliseconds, this little bunch of code runs. And basically, it walks through the list of sprites. And for every single sprite, it tells that sprite to move. It doesn't know how sprites move. It just tells the sprites to move. It's a legal method. And then it tells the whole screen to repaint. And then finally, we have the paint method. And again, this just goes through sprites one at a time. And for each sprite, it tells them to paint themselves. And again, it doesn't know how sprites paint themselves. So let's look at a sprite. And then inside sprite, sprites have a couple different things. They have a, don't want to go anywhere. Sprites have an XY position, and then they have a speed at dx dy. They have an angular position, and then an angular speed. We have the constructors, but then down in move, every sprite knows how to move. Basically, every time the move occurs, we're going to change x by dx, y by dy, and theta by d theta. And then, interestingly, we need to bounce, right, when we hit the edge. So basically, we say if our left edge is hitting the left side, bounce, and so forth. But the challenge is we don't actually know where the left edge is because we don't know what shape we are. And that's something we're going to abstract away. We're going to say, well, we'll figure that out later. So we define these abstract methods, get left, get right, get top, get bottom, that the future instances of sprite will need to define, but we don't know how to define it yet. And we'll also say all sprites are going to know how to paint themselves, even though the base class sprite is really no object, there's no visual, tangible thing to touch at this point, so there's nothing to paint. So other sprites extend from that. So let's look at a circle sprite. So our circle sprite is just a circle. It has a radius and a color. So to paint itself, it basically does a fill oval, right? It knows how to paint itself. And then we can calculate the left, right, and so forth by doing the x position minus radius plus radius and so forth. A wheel sprite extends circle sprite, and it doesn't need get left, get right because those were already defined in circle sprite. So we can take advantage of that inheritance which already filled those in. And then to paint it, actually we paint the circle and then we blank out the middle to create the wheel appearance. So we call the super paint, and then we do our paint. Beach ball sprite is a little different. Again, that extends circle. So it has the same concept of get left, get right, get top, get bottom, and all such. But the paint is going to be different. So inside the paint, it's like we don't call super paint here because we're not going to call this the circle sprite painting. And then we go through and we create three arcs, each of them 120 degrees. And rectangle sprite, it defines its own get left and get right. And these are based upon the width and height of the rectangle, where a circle only had a radius. And then we have a paint as well. So again, the beauty of this is if we go back to the bouncing panel, it doesn't know about any of the complexity. when it tells the sprites to move, it just says move. And inside Sprite, it doesn't understand what the shape of the objects are. It just says, okay, let's move the thing, and if our left side is hitting, do something. But it doesn't know when the left side will hit and so forth. So this is where polymorphism is super powerful, where we can kind of have concepts built upon concepts and abstract away some of the complexity. So I encourage you to go in, play with the bouncer code, and then you can continue on to the next part of the lesson.